Okay, welcome. So we're going to continue. Okay, today we're going to talk about geometric sequences or exponential functions. Okay, you're going to hear them be talking about the same thing, exponential functions and geometric sequences. So if you like formulas, then this is the lesson for you. Okay, it's very similar to yesterday, except we have two more formulas. Again, you need to memorize them. So let's just start from what a sequence is. A sequence is a list of numbers in a particular order. Okay? Geometric sequences is a sequence created by multiplying previous terms by a constant. Okay, when we talked about linear functions and when we talked about arithmetic sequences, that you increased or decrease by a constant. Geometric, you're multiplying by a constant. Okay, so for example, 2 to 6, okay, you're multiplying by 3. 6 and 8, multiplying by 3. So 6 times 3 is 18. 18 times 3 is 54. So on and so forth. You're not adding this time, you are multiplying. And that's when you know it's geometric, is when you're multiplying. Okay, you know if it's arithmetic, if you're subtracting or adding. Okay, there is a difference. The common ratio is the number that the term is multiplied by. To get the next term. Okay. So for example, find the common ratio in this example. Okay, a good way to kind of see what that ratio is divide. So 15 times 3 is going to give you 5. Okay, and then check, what's 3 times 5? 15. What's 15 times 5? 75. Okay, so you always have to check to make sure it's true all the way down, because it can change. This could be times 6 or plus 6, or it has to flow. Okay, you have to have a common ratio all the way through, but that's how you would find it. Okay, you would take one term and divide it by the other. And then you can kind of see where it's multiplied. But you could kind of look here and say, oh, it's multiplying by 5. But if you have big numbers, that's kind of how you would do it. You're taking your second term divided by the last one, and then see if it's true. So there's two formulas you need to learn, okay? And you can be good at both of them. The first one is recursive formula, okay? So consider the following geometric sequence, 2, 10, 50. Okay, let's find the fifth term, okay? So finding a term this way is called recursive. Okay? It's useful for finding smaller terms in a sequence. Okay? So you're not going to use this formula if you're trying to find the 100th term or the 1000th term, because that's going to take forever. Okay? But the reason why we can use this is just look here. 2, what's multiplying by 2 to get to 10? And multiplying by 5. Okay, what about 10 to 50? Multiplying by 5. So if this keeps going, and I want to find the fifth term, okay, I need to find 2 more. So I'm going to multiply by 5. 50 times 5 is going to give me 250. 250 times 5 is going to give me 1,250. So this is my fifth term. Now can you imagine if they wanted us to find the 100th term? Okay, it will keep going on and on and on, and we do not have time for that. But for smaller numbers, it's super easy. Okay, it's efficient. We can use it. That's the recursive formula. Okay, this is the actual formula. You have an equals r times a to the n minus 1, and that looks like a lot, but just look. This is the ratio. Okay, and then this is the term before the one they want you to find. Okay, so it says use this rule to write a rule for the sequence, then find the sixth term. So I'm going to write out my formula. Okay, first of all, we just found my ratio. What's my common ratio? 5. Okay, so I plug 5 in for that, times, okay, they want us to find a to the 6th. That n means the term. Okay, this means we need to find the term before the 6th. So if I were to plug it in, 6 minus 1 is going to give me 5. Okay, and we just found this term up here. So this would be like A1, A2, A3, A4, A5. So we're going to plug this in for A5. Okay, and that would give me 6,250. Now, a lot of you could do it this way and not use the formula because you are smart and you don't like to do what the formula says. However, on the EOC, on your assignments, they're going to ask you to give you the formula. Okay, this would be the formula that they're asking for. Okay, this right here. So you have to be able to know recursive. If they want a recursive formula, that's what they want. Okay, so now what happens if they want us to find a 100th term where you have the implicit rule? Okay, so what if we wanted to find a 100th term? That would take a long time. So there is a faster way to find larger terms called the implicit rule. So let's look at this formula below. Okay, A1 means your very first term of the sequence. Okay, so it says use the formula to write the implicit rule for the sequence above. So talking about this one up here. Then find a 100th term. So I'm going to write down my formula, and it wants us to find the 100th term. Okay. So my first term in the sequence above, let me pull it down so you can see, is 2. So I'm going to put 2 in for A1 times my ratio. Why am I all multiplying by 5? Okay, raised to the n minus 1. So 100 minus 1 is going to give me 99. Okay, put that in the calculator. So you do 2 times 5 raised to the 99th power, and you can get something that looks like this. So you're going to round, okay, to the hundredths place, 3.15, and then times, you see that E? That means times 10 raised to the 69th. Big number. That's in scientific notation. But that's how you would convert back and forth. Okay. So again, up here, there is a difference. Okay, this one does not have an exponent. Okay, you're just strictly multiplying it. This one does. Okay, exponential function right here. Okay, this would probably be the most important one for you to know because it will save you a lot of time. Okay, so that's that. Okay. Again, n minus 1 means the term before, because if you're trying to find a 100th term, the one before is going to be 99, and you're going to solve it. Okay. So now let's do some practice problems that you might see on your assignment. So this says identify each as arithmetic, geometric, or neither. Okay, so first of all, let's look at the first one. Am I increasing by the same number? Can I add and get 4.5? And can I add by that and get 13.5? No. So let's try multiplication. Okay, I can easily do, to find if this is true, 4.5 divided by 1.5 gives me 3. So 1.5 times 3 is going to give me 4.5. So what's 4.5 times 3? 13.5. That's true. 13.5 times 3 is 40.5. That is true. So my ratio is 3. Okay, you have to check it to make sure it's true all the way around, because if you don't, then it could have slipped up and then it wouldn't no longer be geometric. So since you have a common ratio, it's going to be geometric. Okay. Let's look at this next one. 42, 38, 34, 30. Okay? Am I decreasing by anything? Yes, decreasing by 4. Let's see, 38 to 34, same thing. 34 to 30, same thing. Okay, this I have a constant decrease. So it's going to be arithmetic. Okay? It's only geometric if you have a ratio, common ratio. Okay? It is linear function if it's like this. Exponential function, linear function. So on the EOC, they might give you this graph. Okay? And they're going to give you different answer choices. Some's going to be in slope-intercept form. Some's going to have like some funky stuff going on to it, like that. Okay, and you have to tell me which one best represents this graph. Okay, it's not always going to be linear functions because you've also learned exponential. So you're going to have to be able to identify which one is which. Okay, so let's look, always look at your f of x or your y. Okay, so from 8 to 16, I add 8. But do I add 8? If I do 16 plus 8, do I get 32? No, I don't. So it's not going to be any of my linear choices. So now let's see if it's exponential, okay, which also means geometric. So if I do 8 times 2, I get 16. 16 times 2, I get 32. 32 times 2, I get 64. So it is geometric. So my common ratio is going to be 2. Okay? And I'm going to use the simplistic formula, which is a n equals a1 times r to the n minus 1. Okay, so a1, my first term in the sequence, is going to be 8. Okay, my common ratio is going to be 2. My n minus 1, okay, is going to be n minus 1. Okay, just leave it like that because we're not solving, they're not asking us to find anything. All they want is that equation to this graph. So I'm going to have an equals 8 times my ratio n minus 1. So now if they told us to find the 1,000th term, we could plug that into the formula and get that. But this is the equation that matches this line. So you would choose something that looked like that. Okay? So I want you to try this one. Okay, you have this sequence. Okay, find the explicit and recursive formula. Okay, so there's two things you need to find. Okay, go ahead and pause this video, and when you're done, come back for the solution. Okay, welcome back. So the first thing we need to do is find my ratio. So it looks like I'm multiplying each thing by 2. So my r is 2. So my explicit is going to be an equals a1 times r to the n minus 1. Plug in my information. a1, the first number is going to be 5. So that's the first one that comes. Times my ratio 2 to the n minus 1. And that's my answer. Okay. Now recursive. that formula is a(n) equals r times a(n) to the minus 1 equals, my ratio is 2, and then a(n) minus 1. We don't know until we know what they want us to find. Okay, so those are the two formulas for this. Both mean the same thing, except this one will give you smaller numbers. This one works when they want you to find something outrageous. Okay, so if you have any questions, please let me know. But that is all for today. Y'all have a good day.